Okay, we'll have a look at a problem where we load to keep the after draft constant. We're told our drafts initially are forward and aft, and we need to calculate the maximum cargo to load to complete at the vessel's summer displacement. So, first of all, vessel's summer displacement, in other words our final displacement after we finish loading, go into the general particulars and we find it's 19006, and our final draft will be 8.867. So we'll have a final draft of 8.867, a displacement of 19006. 19006 there. So to work out how much cargo to load, we simply use our two drafts to calculate our true mean draft, go into the tables and get our displacement at the true mean draft. So usual procedure, average mean draft, LCF, true mean draft. From the tables gives us 17,151 at 8.096. The cargo to load is simply one subtracted from the other. So that's the answer to part A, pretty straightforward. Just get the two drafts and the balance of the displacements is the cargo to load. Now we need to calculate the position to load the remaining cargo in order to keep the after draft constant. So it's the LCG of this weight that we need to find, and the aft draft has to be constant at 8.867 because that's going to be that's the draft we're going to load to, 8.867. So we need to keep it constant at 8.867 to solve the problem. And we're told here aft draft 8.867. To solve the problem, we need to draw up the table where we have initial displacement, LCG, moments, cargo that we've loaded. We need that LCG in moments. So a couple of values we need to solve this. We need our initial LCG and we need our final LCG. Well, the initial LCG, we do our usual to solve that, which you'll have done before on problems. LCB from the tables at our true mean draft that you've worked out, MCTC displacement at that draft. We know our trim, difference between our two drafts initially, therefore we can find our initial LCG, 67.67. And we know that LCG is total moments over total weight. Total weight is a complete number, that's fine. The moments, of course, we've got the x in because we're looking for the distance x. So the moments here are 1855 times x, which is the distance. Well, because we need to finish at an aft draft of 8.867 constant, that means we're actually at even keel because our summer load draft is 8.867. So we're going to be, our true mean draft is 8.867, aft draft 8.867, we're at even keel. Therefore, at even keel, LCB and LCG must be the same value in the tables. So if we go in the tables at 8.867, we can find an LCB of 69.19, and that has to be our LCG. So we know that LCG is moments over weight, so we can say that 69.19 equals the moments divided by the weight, which are written there. Cross multiply, get x on its own, and we find that it's at 83.24. So that tells us that our cargo has to be positioned 83.24 metres forward of the after perpendicular to keep the after draft constant. And if we put that 83.24 in here, you could then work that out and you'll end up with a final LCG of 69.19 if you wanted to check your working out, of course. So that's how we would solve that problem to keep our after draft constant.